Unit 6, Lesson 2, I hope this is recording, deals with factoring and the factor flow chart. The first method you're going to use to factor is by the GCF, which is the greatest common factor. So in order to find the GCF, the greatest common factor of terms, you have to look at each leading coefficient and see if they have any in common. So when we start with these exercises, 1a, 12, we just want the prime factorization. I want the prime factorization of 12. So that way if there's another number in this polynomial, you can see what number they have in common, and you can take it out of the polynomial. So you can do your tree. 4 times 3 is 12, and then 4 goes down to 2 times 2 times 3. That's a prime factorization. Doesn't matter how you start. Like for 30, I can do 10 and 3, 6 times 5. So if you do 6 times 5, the 6 goes down to 3 times 2 times 5. That's fine. Even if you did the 10, you would have the 5 times 2. 16, same thing, 4 times 4, which is 2 times 2 times 2 times 2. 36 breaks down 9 times 4. 9 is 3 times 3. 4 is 2 times 2. And that is the prime factorization. You do not have to go through that process every single time that you want to try to factor. So when I look at exercise 2, I have 5x plus 10. I want to factor so I can solve, or just represent it as an expression. I don't have to look and list the factors of 5. I don't have to list the factors of 10. You should be able to look at this binomial and say, yes, I can take a 5 out of each term. So then I am left with an x plus 2. You want to make sure that if you redistribute the 5, you will end up back to your original polynomial. Letter B, I take out a 2. I'm left with an x minus 3. Letter C, now the past 2, we were able to take out the leading coefficient. We took out the 5 in the first one, we took out the 2. We cannot take a 6 out of 15. Remember, we have to take it out of both terms. The most we can take out is a 3. And then I have 2x plus 5. And if they have them mixed up in order, it's not a big deal. Follow the same process. We take out the 2, and we have 3 minus 7x. So that's taking out a GCF, just the numeral part of it. You can also have a polynomial with x's in both terms. If there's an x in each term, you can take an x out of the term. So when I look at 3x squared and 6x, I can take a 3 out. I can also take an x out. Then I am left with x plus 2. Next one, I could take a 5 out and an x. Therefore, I am left with 4 minus x. Letter C, I could take a 5 out, take an x out, and I will be left with 2x plus 5. And you could redistribute any of these to make sure that it gives you back to the original. So I can redistribute, and it will bring me back to the original binomial. Letter D, I could take a 10 out. Okay, don't force an x to come out if it doesn't have it in both terms. And I am left with a 3x minus 2. Remember, this is just, 3x squared. And this is just factoring. That's it. We're not solving anything yet. In exercise 4, it's multiple choice, rewritten in factored form. 20x squared minus 36x is equivalent to, well, you know you could take an x out. You know that needs to be subtraction. Okay, so you can get rid of this one. Okay, number 3. You want to find the greatest common factor of 20 and 36. So, you know, 2 goes into both of them because it's even, but 4 also goes into both of them. So if you looked at choice number 1, you see there's a 2x. But if you look at the 10 and the 15, I can still take an additional value out of there. I can still take more out of the 10 and out of the 15. Okay? So you want to make sure you get the greatest common factor. So this is going to be 4x, and therefore I have a 5x to get me back to the 20x minus 9, because 9 times the 4x gives you back to the 36x. And that is choice number 2. Not just binomials. I don't know what's going on my screen. But you can also do factoring of a trinomial with GCF. Okay, I think we're working. So it might get a little more complicated, but your factor flowchart, you always check for a GCF first. So when I look at 2x squared plus 8x plus 10, clearly a 2 can come out. Not every single term has an x. So you have a 2, and then you are left with x squared plus 4x plus 5. And that's as far as you can go for now. Letter B, I have a 10, a 20, and a 5. A 5 can come out of every single term. I have a 2x squared minus 4x. Now this last term is sometimes forgotten. It is a plus 1. Do not forget the plus 1. If you're factoring out of a trinomial, you must have a trinomial left in your parentheses. C, you have an 8, a 12, and a 20. Yes, 2 goes into every single term. Bigger would be a 4, because you can't take a 6 out of every term, and you can't take an x out of every term. Now we also have an x in this one, because every single term has at least one x in it. So I have 4x, and then it says 2x squared minus 3x plus 5. Letter D, 6, 15, 21. I can take a 3. With the x's, the max I can take out is just 1x, and then I'm left with 2x squared plus 5x minus 7. And that's the GCF of those trinomials. The factor flowchart, the second method in our factor flowchart is the difference of, look at this, this is crazy, is the difference of two perfect squares. I don't even know where I am on that page. I don't know what happened. Okay, we're almost done. So hopefully we don't have any more glitches here. So, like I said, a second part of the factor flowchart is difference of two perfect squares. So if you have two perfect squares, x squared minus a squared, that's the difference. It will factor to x plus a, x minus a. Okay, difference of two perfect squares. And it doesn't matter, it doesn't have to be